Hello, dear student. How are you doing? I hope you are preparing for your PT1 test. We are going to continue with chapter number 3, metals and nonmetals. We had finished with the physical properties of metals and nonmetals, and now we are discussing the chemical properties of metals. Till now, we have learned what happens when metals are burnt in air. We have discussed various metals, how they are reacting with oxygen in air. The second chemical property that we have discussed last video was what happens when metals react with water. Today, we are going to discuss the next chemical properties of metals. So let us begin with the chemical property metals reaction with acid. What happens when metals react with acid? Metals react with acid as metals themselves behave as a base. And we have learned in the neutralization reaction in acid, base, and salt that base react with acid to form salt and water. So here, the metal acting as a base will react with the acid to form salt, and during this process, hydrogen gas will released out. The equation is metals reacting with dilute acid giving salt and hydrogen gas. Let us see the activity 3.11 given in your book. Collect all the metal sample except sodium and potassium again. As sodium and potassium are highly reactive, we have seen that they react vigorously even with the cold water. So, here, when we are discussing the activity experiment, sodium and potassium will not be taken. We will discuss with the metals like aluminium, zinc, magnesium, and iron how they are reacting with the acid. So we can put these samples of metals separately in the test tube containing dilute hydrochloric acid. And we can also place the thermometer in the test tube so that we can measure the temperature and find out whether the reaction taking place is exothermic or not. When we are treating the metals with hydrochloric acid, we will observe the rate of formation of bubbles carefully. We will observe which metals react vigorously with dilute hydrochloric acid. We will also see with which metal did the highest temperature occurs. And then we are going to arrange these metal sample in the decreasing order of reactivity with dilute acid. Let us now discuss which metals react with hydrochloric acid and then we will going to arrange these metals in the decreasing order of reactivity. Let us see first magnesium metal reacting with dilute hydrochloric acid. Magnesium will react with HCl forming magnesium chloride and hydrogen gas. How we will notice that the gas released is hydrogen? We can bring a burning matchstick near the mouth of the test tube in which we have taken magnesium and hydrochloric acid. The matchstick will burn with a pop sound indicating that the gas released during the reaction is hydrogen gas. The container in which the reaction is carried out will become warm, indicating that the reaction between magnesium and hydrochloric acid is exothermic. Now, let us see what happens when aluminium is reacting with dilute hydrochloric acid. You can see here in this picture when we are taking aluminium foil and adding it into the acid, the reaction will take place forming the salt and hydrogen gas will released out. Let us see the reaction which is taking place here. You can see here the second reaction, aluminium, reacting with hydrochloric acid, giving aluminium chloride and hydrogen gas. Let us see how this reaction is being taking place. Students, you have already studied in your previous class about the valencies of the elements and how to frame the formulas of the compound. So we already know that the valency of aluminium is 3. So you can see here aluminium is having the valency 3. So when it is reacting with the hydrochloric acid, it reacts with 3 atoms of chlorine, giving its 3 electron. Chlorine is accepting the 1 electron, and as a result 3 chlorine will accept the 3 electrons of an aluminium, so it will form the compound AlCl3, and during this process the hydrogen gas will be released out. Similarly, you will notice zinc and iron will also react with hydrochloric acid. Zinc will react with hydrochloric acid, forming the compound zinc chloride and hydrogen gas. Iron reacting with HCl, forming iron chloride FeCl3, and during this process hydrogen gas is released out. Copper, as we already seen in the reactivity series, is a least reactive metals. So here copper is not reacting with dilute HCl. We will notice that when the metals are reacting with hydrochloric acid, the container becomes warm, indicating that the reaction between metals and acid is an exothermic reaction. Let us now discuss how metals are reacting with nitric acid. We have seen in these reactions that when metals are reacting with the acid like hydrochloric acid, they are forming salt and hydrogen gas is released out. But here we will see that when metals are reacting with nitric acid, HNO3, hydrogen gas is not evolved out. The reason is that nitric acid is a strong oxidizing agent. So, it will oxidize the hydrogen gas produced during the reaction to water and will itself undergo reduction, forming the nitrogen dioxide. Children, to understand the oxidation and reduction or oxidizing agent or reducing agent, please refer chapter number 1 so that you can understand this reaction nicely. So, metal will react with the nitric acid, forming metal nitrate, water, and nitrogen dioxide gas. Here, there is an exception. Magnesium or manganese can react with a very dilute nitric acid, and in that, hydrogen gas is evolved out. As we are discussing metal reaction with the acid, let us study about a solution which is known as aquaresia. Aquaresia, Latin for royal water, is a freshly prepared mixture of concentrated hydrochloric acid, and concentrated nitric acid in the ratio of 3 is to 1. It can dissolve gold, even though neither of these acids can do so alone. Aquaresia is a highly corrosive fuming liquid. It is one of the few reagents that is able to dissolve gold and platinum. Let us now see the next chemical property, how two metals react with the solution of other metal salt. In order to understand this chemical property of metal, let us first discuss the activity 3.12 given in your book. In this activity 3.112, it has been asked to take copper wire and iron nails. We'll take a test tube containing iron sulfate solution and will dip copper wire into it. And then we are going to take another test tube containing the solution of copper sulfate. In this, we will place iron nail. We will record the observation after 20 minutes. We will notice that in which test tube did the reaction has occurred. On what basis we can say that the reaction has actually taken place? You can see here the figure given, and you can see the copper sulfate solution in which iron nail is dipped, and iron sulfate solution in which copper wire is being dipped. So what we are going to observe is iron is more reactive than copper. It will displace copper from copper sulfate solution and will form ferrous sulfate. Copper sulfate solution is blue and ferrous sulfate solution is green. So the solution will turns green from blue. This is the reaction which will take place. Fe plus copper sulfate solution will give on reaction ferrous sulfate FeSO4 and Cu. Now, what we are going to observe in another test tube in which we have taken copper wire dipped in iron sulfate solution. Here we will notice that no reaction has taken place, and the reason is copper is less reactive metal than iron. So it is not able to displace iron from iron sulfate solution, and as a result no reaction has taken place. This is a displacement reaction, as a more reactive metal can displace less reactive metals from their compounds in solution or molten form. We have seen in the previous section that all metals are not equally reactive. We have checked that the reactivity of various metals with oxygen, water, and acid. But all the metals do not react with these reagents. Some react vigorously, some at moderate rate, and some do not react at all. This displacement reaction is a better evidence about the reactivity of metals. It is simple and easy. If a metal displaces another metal from its solution, it means it is more reactive than the other. So, on this basis, we can prepare a series and we can place the metals in the order of their decreasing reactivity. You can see here the reactivity series. As we already know now, sodium and potassium are at the top, showing that these are the most reactive metals. Then calcium, magnesium, aluminium, iron are reactive, but they react at the moderate rate. Metals like lead and copper are least reactive, while the metals like silver and gold do not react. We are going to continue with this reactivity series in our next video, and we will see what is the meaning of reactivity series, how we are going to define it, and we will also understand why the hydrogen is placed in this reactivity series. So we'll continue this in the next video. Thank you for listening, and till we meet in the next video, take care of yourself.